Hi guys, welcome to your physics lesson for grade 12. In this lesson, we're going to be speaking of the conservation of energy. We've done this before, so what do you remember from the previous video? Do you remember what the law of conservation of energy was? Do you remember some energy types that we discussed? In this video, we're going to discuss the various different types of energy that can occur. We're also going to look at what the conservation of energy entails by doing another calculation. Do you remember when we discussed conservative and non-conservative forces? We also discussed how it affects our conservation of energy. Remember, wizards, that those aspects are very important in order for you to do your calculations. This one is going to introduce something completely different. So let's jump into the example and see if we can complete them together.
So we want to look at using the same example that we used in the previous video. Do you remember we spoke about the footballer who slid to a stop and it took him 2,6 meters to come to a stop? Well, we want to look at the same example and try to see how we can now look at the conservation of energy and the formulas and see what we arrive at. The example said that the same 65 kg player running at the same speed of 6 meters per second dives up an inclined embankment that is located at the side of the field. The force of friction is still 450 newtons as it is the same surface, but the surface is now inclined at 5 degrees. How far does he slide now? So friction stops the player by converting his kinetic energy into other forms. Remember that we said thermal energy, just as in the previous example we worked with. The difference in this case is that the height of the player will change, which means a non-zero change to gravitational potential energy. So what are we saying? We're saying we now need to include that. The work done by friction is negative because remember that friction is in the opposite direction to motion. So let's try to build a sketch. If we had to build a sketch, we can say that we want to look at a triangular embankment, and that embankment will have a distance. What else will it have? It has a degree, and that degree or theta is equal to 5 degrees. So what would h then be? What would height be? Height, using trigonometry, means that we're going to get d sine theta. Can we see that? Once we have d sine theta, we can look at doing the formula. In this case, the work done by the non-conservative force on the player reduces the mechanical energy he has from his kinetic energy at zero height to the final mechanical energy he has by moving through the distance to reach the height that we have. And this is along an incline, so we can represent the equation as follows. We can say work by the non-conservative force is equal to the change in kinetic energy plus the change in potential energy. What is the formula for kinetic energy? The change in kinetic energy is equal to kinetic energy final minus kinetic energy initial plus potential energy final minus potential energy initial. So that's the full example that we have. So when we look at this, if we only wanted the final energy and the final potential and kinetic energy, can I then say work of the non-conservative force? If I bring the plus on the negative on this side, I get plus energy kinetic initial. Bring it the negative on this side, plus energy potential initial is equal to energy kinetic final plus energy potential final. So what do we know? We know that the work done by friction is equal to negative forces because of your force of friction. We know that the initial potential energy is equal to 0. We know that the initial kinetic energy is equal to half v squared. And then we look at the final kinetic energy, which is 0. And then the final potential energy, which is going to be equal to mgh, which is mass, gravity, and height. But remember that we are looking at height here as being d sine theta. Putting all of that into consideration, what do we have? What are we saying? We are saying that this work, non-conservative, is equal to the negative force of friction times the distance. What else are we saying? We're saying that the initial kinetic energy is half mv squared. Then we are saying the potential energy initial is equal to plus 0, because we're saying that that's 0. And the kinetic energy final, also 0, plus potential energy final. What is the potential energy final? We said that it's going to be mgh. So now we have mg, and h is represented by d sine theta. Once we have all of that, what can we do? Can I bring this mg on this side and take my kinetic energy onto the other side? Let's do that. I get minus force of friction d minus mg d sine theta equal to minus half mv squared. And remember, this is the initial. Once I do that, I can say that here I have d as a common factor. So if I take out the d as a common factor into negative force of friction plus mg sine theta, this is going to be equal to half mv initial squared. And can you see that we removed the negative sign because we had negatives across? So let's rewrite that. Let's say we have d into minus force of friction. And remember, force of friction can now be taken as positive. So I'll have my positive force of friction plus mg sine theta equal to half mv initial squared. And then now I can start to find d. So if I wanted d on its own, I'd get half mv squared all over force of friction plus mg sine theta. Let's do it. We would get half. What was his mass? The mass was 65 kgs. What was the velocity? That's right, 6 meters per second squared. All over, what was the force of friction? They said that it remained the same at 450. Plus, mass again, 65. What is gravity? 9,8. And then I have sine, and they said it was at 5 degrees. When I put all of that into my calculator and I round off my answer, I get 2,31 meters. How will I state it? I will state that the player slides 2,31 meters before coming to a stop. What are the important things to remember here? The first thing that's important to remember is that the work done by friction is negative. Why? Because friction acts opposite to motion. The initial potential energy was 0 because he was moving. The initial kinetic energy was given by a speed of 6 meters per second. Once we calculated it using his mass, we could have got our kinetic energy initial. The kinetic energy final was 0 because he was not in the motion. He was not moving. He was not doing anything. He had come to a stop. And the final potential energy was calculated using the angle of inclination. So with this, it's very important that you look at all the aspects that you have, and you can see how when the player slides on a flat ground with no incline, how the answer is affected. Remember that previous to this, his stopping distance was 2,6 meters. So the distance, if you are going up an incline, is reduced. That means it takes a shorter distance for him to come to a stop as opposed to before when he made it at a larger distance, 2,6 meters. And here, using an inclination of 5 degrees, that means that he stopped at 2,31 meters. So you can see the difference.
Okay guys, I hope you follow that example really closely. Try to watch it again or try to look for those videos on our iWhiz website. Also remember that you need to follow the examples with me so that you can understand what is happening. So wizards, for more information as well as worksheets, log on to the iWhiz website that's appearing on your screen. In those worksheets, you will be able to identify your problem areas and the areas that you need to work on. If you need any more assistance, you can log on to the iWhiz app. By using the app, you can get examples as well as more lessons, even textbooks to help you improve your knowledge on this section. Remember wizards that it's quite difficult if you do not follow the examples as we go with them. So wizards, log on to the iWhiz app and download those worksheets. Remember to complete as many as you can. Good luck wizards!
We need to learn to live with the COVID virus, you know, the new normal, at least for the next few months. And we have just what you need to make sure you never miss a single school lesson. And it's absolutely free, mahala! High quality, powerful, animated lessons for all your subjects. So don't spend a cent until you have tried iWhiz. It's everything you need. All video lessons, textbooks, workbooks, exam prep. We want you to ace 2021.